Welcome to this explainer. Okay, let's be real for a second. If you're tired of treating generative AI like just some glorified search engine, you are absolutely in the right place. Today, we're unpacking the insights from the highly anticipated sixth session of our source material, all about the art of strategic cost reduction. We're going to look at how to actually leverage AI as a seriously capable analytical co-pilot in complex manufacturing environments. Let's just dive right in. Because, the manufacturing landscape today, it's incredibly complex. We're dealing with volatile raw material prices, crazy energy costs, and constant supply chain risks. So the million-dollar question we really have to ask ourselves is, how do we generate faster, better, and actually executable cost-saving ideas in such a demanding environment? Relying purely on past experience? Yeah, that just isn't cutting it anymore. We absolutely need a new approach to uncover those hidden, actionable savings. To get us there, we'll walk step by step through this session's framework. We're hitting AI cost reduction basics, problem structuring, data and pattern detection, correlation versus causation, KPI validation, and finally, human and AI synergy. All right, Section 1, AI cost reduction basics, a structured approach. Let's get our foundational framework set.
So cost reduction isn't just about, throwing a mountain of data at a wall and hoping something sticks. It's a really rigorous, interconnected three-step procedure. Step 1 is cause structuring, pinning down exactly where the problem is happening, whether that's raw materials, energy, or chemicals. Step 2 is AI-based idea generation, where we use the AI to explore a huge range of alternatives we probably wouldn't have thought of. And Step 3, strict feasibility validation, basically checking if it actually works on the production floor when it comes to cost, quality, and safety. If you skip or even rush any of these steps, the whole shebang just kind of falls apart.
Moving right along to Section 2, problem structuring and prompts, guiding the AI.
So how do we actually get those golden ideas out of our AI in Step 2? Well, if AI is our co-pilot, we're the pilots, right? We have to give it the correct flight map. This brings us to a concept heavily highlighted in the sixth session material called context engineering. It's this absolute crucial step where we don't just ask some simple question. Instead, we structure our process data and our operational environment into a highly logical query. Rather than just typing, hey, how do I increase yield? Context engineering means you're feeding it the specific problem situation, the expected causes, your target goals, and the actual hard process data, like temperature variations or steam usage.
And this leads to a brilliant core truth. Good questions make good answers. And AI's performance is honestly driven way less by the massive size of its neural network and much more by how logically we structure our prompt. If you feed it a vague, fuzzy problem, you're going to get a generic textbook answer. But if you provide rich, field-specific context, the AI responds with concrete, actionable engineering solutions. It's a real game changer.
Okay, Section 3, data and pattern detection, the core dynamic.
With that proper prompt engineered and our context locked in, we can finally unleash the AI on those massive datasets. The data-driven workflow relies on a very specific sequence. First up, we collect diverse data, process, quality equipment, energy metrics, you name it. Next, the AI does the heavy lifting in Step 2 to find hidden patterns across these variables that a human might totally miss. But Step 3 is where you come in, cause interpretation. Finally, Step 4 is validation. The AI might spot the pattern, sure, but it takes a human to turn that pattern into an actually solved problem. The absolutely crucial takeaway here is this. Data is analyzed by the machine, but meaning is interpreted by the human expert. AI is phenomenal at telling us what is happening simultaneously across thousands of data points. But actually, let me rephrase that. It knows what is happening, but it completely lacks the field experience to tell us why it's happening. That interpretation, that is entirely up to you.
Which brings us nicely to Section 4, correlation versus causation, steering clear of mirages. That absolute need for human interpretation leads us to the most dangerous pitfall in data analysis, and it's one that this session of our source material warns us about extensively. We have got to separate correlation from causation. AI detects correlation. It just finds things that happen to occur at the exact same time. But humans must step in to prove actual causation, proving that one thing literally caused the other thing to happen. Taking AI's correlation as fact without testing it is basically a recipe for wasting a ton of time and money on the completely wrong fixes.
Imagine this scenario out on the plant floor. If steam usage spikes right when your product yield drops, the AI is going to immediately flag that pattern. It looks like a smoking gun, right? But the engineer has to investigate the physical plant to prove it wasn't just some random coincidence. Maybe the steam usage spiked because of an entirely different process running nearby, and the yield dropped because a catalyst degraded. Just because they happen together absolutely doesn't mean one caused the other.
So before taking any action out there on the floor, you've got to filter the AI's ideas through 3 strict criteria. First, repeatability. Does this pattern happen consistently, or was it just a one-time fluke? Second, explainability. Does this make logical engineering sense based on the actual physics of the plant? And third, executability. Can we realistically implement this fix given our budget and our downtime constraints? If an idea fails these tests, it stays on the whiteboard. Period.
All right, moving into Section 5, KPI Performance Validation, Landing the Plane. Let's see how this all builds into the next critical phase. Once an idea actually survives that strict filtering process and is implemented, we have to simulate and track its real-world impact. We literally have to land the plane. This means setting highly specific, quantifiable goals way before you execute, say a 5% energy reduction or maybe a 2% yield improvement. Setting these hard numbers allows the AI to simulate different scenarios beforehand, and even more importantly, it gives you a concrete benchmark to evaluate your true ROI afterward.
Our source material hits on a classic industrial truth here. If you want to improve it, you have to measure it. If you don't have a specific key performance indicator, a KPI, attached to your AI-generated idea, you are honestly just guessing. KPI tracking is the ultimate reality check. It strips away all the AI hype and forces you to focus purely on the bottom line.
And this is where KPI-based validation comes into play. It is all about comparing the before state to the after state, using the exact same metrics. By rigorously comparing our baseline data to the post-implementation results, we objectively prove whether the AI's suggestion actually saved the company money. In this game, the results just have to be proven with numbers.
Finally, Section 6, Human and AI Synergy, the Ultimate Team.
To wrap up this 6-session explainer, let's zoom out and look at the overarching philosophy here. It is not about machine versus human. It's about machine and human. Now, while AI expands our brainstorming horizons tremendously, offering up incredibly diverse alternatives across operations, equipment, and energy that we totally might have missed, it also has very clear limitations. It is 100% dependent on the quality of your data. Plus, it's completely blind to unrecorded field conditions. It can't feel a machine's subtle vibration or rely on a seasoned operator's gut intuition.
That brings us to perhaps the most vital takeaway from all of this material. AI is a decision support tool, but the final judgment belongs to the human expert. AI is never going to replace the plant manager or the process engineer. Instead, think of it as a brilliant co-pilot. It can crunch the data and suggest the flight path, but it absolutely requires your field experience, your context, and your final judgment to fly the plane safely.
So as you head back out to the manufacturing floor after reviewing this explainer, I want to leave you with this to chew on. Are you still feeding your AI vague questions and getting useless answers? Or are you ready to engineer the exact context it needs to uncover real, actionable savings? How are you going to change your prompts tomorrow? Thanks so much for joining me for this session, and hey, happy analyzing.